My name is Richard Steinke, and I am the CEO of Wind-Sail Receptor Inc., and also the inventor of the Wind-Sail Receptor technology. For a technology to become popular, it must be very economically feasible. Wind-Sail Receptor has invented a technology which is going to revolutionize, we believe, the whole alternative energy field. The existing technology used in windmills today and also solar are not cost efficient. What you're going to see today in the video is a cost efficient technology both in operations, maintenance, and in durability and in running with the wind. No windmill can be called a windmill unless it can run at low wind speeds of 4 to 5 miles an hour and run up to wind speeds up to 60, 70 miles an hour. So what you're going to see today is a technology that can do that. Wind-Sail Receptor Inc. has invented a wind turbine technology which is more efficient to operate and less costly to build than any known competitor in the wind energy field. The design of the blades allows more torque for energy power, which initiates less cost per kilowatt hour. In fact, the Wind-Sail Receptor turbine is so proficient that it can even outperform coal or gas technologies in the cost per kilowatt hour. What's the current technology? Well, here you see we have a current windmill where most of the wind passes between the blades without effect. It is inefficient in capturing the motive forces of the wind. The design of the blade does not lend itself to be structurally sound as a windmill blade. High winds create a racking motion which causes a deformity of the blade. Look at the material. The material of the blades is also in question. Being made of a fiberglass and or graphite composite materials, the blades are more vulnerable to cracking in high winds and made brittle by the ozone. The design of the blades is causing a very high-pitched noise to resonate ever louder as developers increase the size of the windmills. And you get this noise through the slapping that occurs as these blades try to go through the wind. The existing windmill technology has become very expensive to build and maintain. Because of its theoretical limit of efficiency, a totally different design is needed in the marketplace. Now, this is the solution to the windmill technology today. As you notice, you can take a look at the structural design of our blades. But here's a small piece that you can see and see just how strong this material really is. This can take tremendous pounding, it can handle the ozone, and this will not break down under the ozone. Meaning that this can last 10, 15, 20 years out there under the hot sun or the cold environment. The material of the blades is proprietary to Wind-Sail Receptor. They are not made out of graphite or fiberglass composite. They are made out of a proprietary polyurethane, and they can handle high and low temperatures without creep or cracking. The abrasion resistance is also much better than a composite. But let's go back to the temperatures. At room temperature, you can take a hammer and hit these other blades and crack them. You cannot crack ours using the hammer at room temperature. These blades that we have on now can handle temperatures of 100 degrees below zero. And you can take a hammer, hit them, and there is no cracking. This is not a thermoplastic material. It is a thermoset material, and therefore will not crack even under those low temperatures, and will not crack at extremely high temperatures of approximately 400 degrees Fahrenheit high.
We receive all the momentum of all the wind forces has to go through those blades. So you notice it came out at a 45-degree angle. That's what you want. So you got all the motive forces of the wind going through this. Now you take a look at the structural design. This material, polyurethane, is going to handle all the forces of nature. That's what you want. We have also no noise.
The reason these don't make noise is that, as Richard said, it is a sail. And if you put a sail up on a boat, as the wind pushes on that sail, it doesn't make any noise. The sail makes no noise at all. It goes along with the wind and produces the power to propel the boat. Well, that's what this does, as opposed to a regular propeller. As a regular propeller cuts through the air, it makes noise and puts stresses on the blade. This acts like a sail, and as the wind comes into this edge, it's actually coming into a sharp edge that's right with the wind flow. So there's no resistance here, but as the wind hits this with no resistance and pushes in through here, that blade moves very easily, as you can see just by getting it from the stop position and pushing straight in just like the wind will on that.
It all comes down to economics. How cheap can you make that kilowatt? And our bet is we can be below coal and natural gas costings of a kilowatt. And that's what our target is, and that's what I believe we have already. If we can get below 5 cents a kilowatt, we have the technology to take over all alternative energy, replace coal, and even replace natural gas.